In this video, we'll integrate secant to the fifth of x dx, and this is going to use integration by parts multiple times. Now, we're going to begin by seeing that secant to the fifth of x would be helpful to rewrite it as secant cubed of x times secant squared of x. And particularly, the reason we chose to split it up this way is the secant squared of x term is very nice because we know if we chose that to be our v, the term that we're integrating, we know the integral of secant squared is tangent. So we'll let u be secant cubed of x, and then we know what will v be. It will be everything that's left over, so that means v would be the integral of secant squared of x dx. Now we need to find du. We're going to use chain rule here because we've got the secant of x that is inside something cubed, so we bring down the power 3, leave the inside the same, subtract 1 from the power, and then multiply by the derivative of the inside. The derivative of secant is secant tangent. And then we use our integration by parts formula. So we know this integral will be equal to u times v, and before I plug in v, I realize I did not integrate that. The integral of secant squared is tangent, so v is tangent minus the integral of v du and let's clean up the interior of this integral. So we have secant cubed of x. Specifically, I think we can make the tangent a tangent squared, bring the secants together. And bring the 3 out front as a constant multiple. So the 3 is a constant multiple, so it comes to the front. The secants combine to be secant cubed. The tangent combines to be secant squared. And at this point, we'll need to think of a helpful trig identity in order to go to our next step. We'll want to recall that tangent squared is the same as secant squared minus 1. So we can replace tangent squared of x here with our secant squared of x minus 1, and then we are going to distribute the interior of the integral, and then hopefully it will look like something that we can begin to integrate. So right now we're just algebraically trying to manipulate this to where we find something that we could integrate. So we have substituted tangent squared of x, substituted in for secant squared of x minus 1, and now we can distribute this secant squared x like that. So we'll simplify the interior in our next row. This would be a good time to pause the video and write out your own simplification after you distribute the interior, and then unpause to check your work. So after distributing, we would get this. And at this point, it would be helpful to remember that we can split, if there's subtraction inside an integral, you could split it into the integral of the first minus the integral of the second, and that's going to be useful to us here. So I'm going to make this the integral of the first. But since I'm splitting it, the 3 has to come, make it clear that the 3 is going to go to both terms, so I include brackets there, minus the integral of secant cubed of x dx. So I've just split it into 2 separate integrals. Now we're going to use different strategies for each integral. Do we see that the first integral, matches what we started with up here. So this is going to be one of those cases where eventually in the problem, we're actually going to add this term over to the other side, and it will join with the original integral of secant to the fifth of x dx, and we'll divide out by a constant. So that's how we're going to take care of this one. We're not going to integrate it, but we're going to move it to the other side at the right moment, and it will take care of itself. So whenever you're using integration by parts and the original integral appears, that's what we always do with that piece. So we know what's going to happen here. Now let's focus our attention to this. If we could just integrate this, then we would have to just substitute and our problem would be done. It doesn't fit any of our known integral formulas. I don't think use substitution is a good choice here, so then we'd want to think about integration by parts. And we might want to do a similar manipulation to what we did above. Notice secant cubed could be split into a secant squared times a secant dx. That's how we could rewrite that. And then in this case, this is perfect for integration by parts because this could be our v term that we integrate and get tangent. This could be our u term that we differentiate. So we kind of have in mind the way we're going to integrate this term here is by integration by parts, but we'll need to do that off to the side because it would be somewhat lengthy. So at this point, I prefer to somehow indicate that I'm going to take this term over. You can call it whatever you like, maybe a star, integral 1, and we're going to work on this on a separate page, and then whenever we fully integrated this, we'll bring it back into the problem and simplify the entire setup. So on a new sheet of paper, we write off our integral. The integral of secant cubed of x dx could be split as the integral of secant squared times secant, and now we're going to use integration by parts. Take a moment to pause the video and write in your u, du, and v term. Here the u would be our secant of x. V would be the integral of secant squared of x, and nicely for us, this is one of our known integral formulas. That's just tangent of x. Du would be secant tangent of dx. Now we apply the integration by parts formula. So this would be u times v minus the integral of v du Now at this point, this is just what it is. There's nothing to be done here except just keep track of it. However, we do need to integrate this term. And before we integrate it, it might help us to try to simplify what we see. So why don't you take a moment to pause the video now and try to simplify the interior of the integral in a way that would help us integrate, and then unpause to check your work. The two tangents would combine to become a tangent squared, and then we've got a secant of x dx, and particularly when we have a tangent squared and the other term is secant, we might recall the useful identity here. Tangent squared is secant squared minus 1. So we just make a note of that. We know tangent squared of x is secant squared minus 1. And then we will replace that. Secant squared of x will take over the tangent of x here. Now just a word of caution, when you substitute that in, if you leave it just like this, it might throw off your work because it's not clear where the secant x is, if it's going just to the 1 or to both terms. So be sure, whenever you substitute things with multiple terms, offset those terms in parentheses. That way it's clear that they would be distributed. So we've made the substitution, and now I think we can simplify our interior again. Remember, if we can simplify the interior, that's probably going to help us be able to integrate it. So why don't you take a moment and pause the video, simplify the interior. When you think that you've done so, Unpause to check your work. So we get that whenever we distribute, we get secant cubed minus secant of x. And since we have the subtraction, we know we can split the integral into the integral of the first thing minus the integral of the second thing. So we have the integral of secant cubed x dx minus the integral of secant of x dx. And we look at this, we know when we're doing integration by parts, if we ever happen to have an integral that's the same as what we started with, we have a particular strategy. And you see one of our integrals is the same as our starting point, secant cubed of x dx. And then the integral of secant of x dx we think is at a known integral formula. And in this case it is. We've done this one previously. It would be back in our 7.1 notes, the first notes of Calculus 2, we did list out some important integrals to know and memorize. And if we look down the list, we do have the integral of secant is the natural log of secant of u plus tangent of u. And if you're curious as to why that occurs, we actually proved that one in our examples. So you could go back to your 7.1 notes. I think some of the very last examples go through why the integral of secant of x dx is the natural log of the absolute value secant of x plus tangent of x. But we'll just cite this here in our example, but you could find these in the 7.1 notes. So we know this integral is equal to the natural log of secant of x plus tangent of x. So what we would do here is let's rewrite from the beginning what we were trying to find. All of this is equal to all of this, and then we'll be able to algebraically move this piece over to the other side. We started with the integral of secant cubed of x dx, and we found that it was equal to secant of x tangent of x minus the integral of secant cubed of x dx minus this integral just becomes the natural log of the absolute value of secant of x plus tangent of x because it's one of our known integrals. And now we're at the final step. See that currently we are subtracting this term, but if we could add this term to both sides, and it would get rid of it from this side, and it would add the other term to here. And because these are exactly the same things, it would simplify what we're trying to solve. So we could say, let's add an integral of secant cubed of x dx to both sides. That gets rid of it from this side. And the left side of the equation becomes 2 times the integral of secant cubed of x dx, because we had one of the things plus another of the things becomes 2 of the things, equals, the right side simplifies just to secant of x tangent of x minus natural log of the absolute value of secant of x plus tangent of x. And in order to solve for this, we're then going to divide both sides by 2, because if we divide both sides by 2, we'll have exactly what we were looking for. So the integral of secant cubed of x dx is exactly 1/2 times secant of x and then we try to focus back, where did this come from? We were finding the integral of secant cubed all the way back, if we look at our work a few pages back, because we wanted to know what this integral was here. So the integral of secant cubed that we found should be all that we just wrote down embedded in this expression, because that whole expression was the integral of what we were looking for, secant to the 5th. So this is where we just want to stay focused and mentally organized. We were doing all this to find the integral of secant to the fifth. As we were doing so, an integral of secant cubed came about, so we did work off to the side to find it, and now we're going to substitute that back in the original expression. So now let's write out our integral for secant to the fifth of x on our next page. So the integral of secant to the fifth of x dx was this expression. Now we know that this integral is equal to this, so we can make that substitution on our next row, keeping in mind that this whole expression was being multiplied by 3. Why don't you take a moment to pause the video and make these substitutions, unpause to check your work. So while I was substituting this in for here, I also distributed the multiplier of the -3 to both terms, so that would make us a minus the integral of secant, 3 times the integral of secant to the fifth of x dx, and then -3 times a negative would become a +3, substituting in this for the integral of secant cubed, and we would get 3 times 1/2 all times secant of x tan x minus natural log of secant of x plus tangent of x. And we see the only remaining integral is this one, but nicely for us, it completely matches this one. So this strategy in integration by parts is then to move it to the other side. So why don't you pause the video and attempt that on your own. Finish up the problem, solve for the integral of secant of x to the fifth dx, and then unpause to check your work. So here we're going to move this integral to the other side because it matches, so we're going to add 3 since it's currently -3. What's done to one side must be done to the other. And then here, even though these integrals look complicated, we want to think of it as one thing plus 3 of those things. That would naturally become 4 of the things. So those cancel from here, and we're left with 4 times the integral of secant to the fifth of x dx equals secant cubed of x tangent of x plus, and here I can distribute the 3 times the 1/2 would just become 3/2 all times The final step is we only wanted the integral of secant of the fifth to the x dx, not 4 times that, so we're going to divide both sides by 4. And then we finish the integral. In integration by parts, we always add our plus c at the end. So this is the integral of secant to the fifth of x dx. And in this case, we had to use integration by parts twice. And if we look through all the work that we had to do to get to here, it is a lot of steps. And since there's so many steps, I think it's really important to stay organized and focus on each piece so that we are able to put it all back together again. So as you work through problems that have multiple integration by parts, keep in mind whenever you're doing one integral so that you can substitute back into the overall expression like that. So if you have any questions about this problem, let me know and I'd be happy to clarify further. Thank you.